In this section, we will learn about strings. So first of all, in this video, I'll give you introduction to strings. For giving introduction, I'll be talking about character sets or ASCII codes. Next, I'll explain what does it mean by character array. Then I will explain string, and we will learn how to create strings in C language. Let us start with character set or ASCII codes. Character set is the set of characters that are supported by a programming language like C, C++ or any other language. So the set of characters supported by a language will be same as the set of characters that are supported by any computer system. We know well that computer system works on binary number system. So everything in computer is numbers. Then how they can support characters? So basically they don't support characters. Then how we make them work on characters? We will define some set of numbers as characters. So it means for every character we define some numeric value. So we give some numeric codes. So yes, for the English alphabets, for every character there are some codes defined, and those codes are standard codes. Every electronic machine follows that same set of codes, and those codes are called as American Standard Code for Information Interchange, that is ASCII code or ASCII codes. These codes are given by American National Standards Institute, that is ANSI, and also it is ISO standard. So that's the reason every electronic device supports these codes for English language. And moreover, for other natural languages like Chinese, Japanese or Hindi, for various other natural languages, the codes are defined, and those are ISO standard codes, and those codes are called as Unicodes. So we will be learning about ASCII codes first, then I will explain you a little bit about Unicode also. So ASCII codes are for English language. Now how the codes are defined? See, for every symbol, for every letter or character, there is a code available. So let us look at English alphabets. So for capital A, uppercase A, ASCII code is 65. Then for capital B, it is 66. So 67 and so on. Like this up to capital Z, and the capital Z, it is 90. So these are uppercase letters and the codes are starting from 65 up to 90. There are total 26 alphabets in English language. So these are 26 codes. For lowercase alphabets also ASCII codes are there, that is 97 for lowercase a, then 98 for lowercase b, 99 and so on, and lowercase z is 122. So these are for alphabets, English language letters. Then for numerical symbols like 0, 1, 2, 3 also ASCII codes are there. So what is the ASCII code for 0? It is 48. Then for 1 it is 49. For 2 it is 50 and so on. Last digit is 9. So it is 57. So these are the codes for numerical symbols. Now basically if you see what all the symbols that you find on keyboard, that forms a character set, and for every symbol on the keyboard there is some ASCII code available. Now the other symbols are remaining, like special characters like opening bracket, closing bracket, comma, question mark, plus, minus and star, so on. There are many special characters, so for special characters also symbols are there. Generally we work with these symbols, so I have written the ASCII codes, and you should remember these ASCII codes. For uppercase English alphabets, lowercase, as well as these numeric symbols. And also for enter ASCII code is 10. For space bar ASCII code is 13. And for escape ASCII code is 27. So these may also be helpful if you can remember them. So this is a set of ASCII codes. So if you see the ASCII codes I have given, that this is 48 to 57, then next is 65 to 90 and 97 to 122. So actually from where they are starting and where they are ending. So that is important. ASCII codes are starting from 0 to 127. Total 128 ASCII codes are there. Total 128 that are starting from 0 to 127. To represent these ASCII codes, to represent any one symbol, 7 bits are sufficient. 7 bits are sufficient. That is binary bits. I guess you know how binary numbers are stored. So you need binary digits or binary bits. So 7 digits are enough. Like 2 power 7 is 128. So it ranges from 0 to 127. So only 7 bits are sufficient for ASCII codes. But while allocating the memory in main memory, that is in the RAM, 7 bits are not allocated. Minimum 1 byte is allocated. So that's why a character, that is the ASCII code, is stored in 1 byte in computer memory. Now I'll tell you a little bit about Unicodes. Like Unicodes are for all the languages. So ASCII codes become the subset of Unicode. So like English is also one of the language, so it becomes subset of Unicodes. Unicodes takes 2 bytes of memory. 2 bytes, that is 16 bits. Right? So because it is supporting all natural languages, and this 16 bits can be represented in the form of hexadecimal codes. So hexadecimal codes are represented in 4 bits. So these are represented in 4 bits hexadecimals, right? That is 4, 4, 16. So these ASCII codes are represented in hexadecimal form in 4 digits of hexadecimal. Like for example, C035. So these are 4 digits of hexadecimal. Or C03A. So this is 4 digits of hexadecimal. So Unicodes are represented in the form of hexadecimal. So you can go to a website called unicode.org. Unicode.org you can visit, and there if you look at the charts for the codes of languages, you can find codes for various languages available. And same way in Google, if you search for ASCII code, you can find codes. There are a lot of websites giving the information about this one. So this is all about ASCII codes. Now next, let us understand how a character is represented and what is character array. Then we will learn about strings. Let us see how to declare a character type variable in C and C++. Our data type is char. So char or char is a data type. And suppose I declare a variable name as temp. Now this temp is a variable of type character. So how much memory it consumes? It takes 1 byte of memory. Then what is the data present here? There is nothing present here. So temp is just 1 byte. And if I want to store something in that, then I can initialize it with a character. Let us say A, capital A. So A is stored here. See, for giving a character constant, it must be in single quotes, and we can give only single alphabet. So for example, if I write temp assign A as well as B and quotes, this is wrong. And if I write A, simply A, this is also wrong. If I write temp A, if I use double quotes, then also it's wrong. So it should be in single quotes, and we should have only one single alphabet, then that will be stored here. Now, what actually is stored in the memory? Actually inside the memory, value 65 is stored. It's 65. It's not A, right? A is not represented in computer memory. 65 is stored. Then next, how to print this alphabet? I can use printf for printing that alphabet. Printf percentile C and temp, that variable name temp. Now the value of temp is 65. So actually printf should print 65, but we have given a control character as C, so it will print letter A on the screen. Instead of C, if I make it as a D, then decimal number, that is integer type, so it will display 65 on the screen. So with this you can understand basically it is 65. As we said that we want this in character form, so printf will print that in A. Then same way in C++, if we write cout, temp, then cout knows that this is a character type variable. It is declared as character, so that is the reason it will display A. So both these will display A. So this is the method of displaying a character. So this is about the character, declaration of a character and initialization of a character, and even I can initialize it here directly, right? Instead of initializing it later, I can declare as well as initialize it. Now next thing we will see what is character array, how I can create an array of characters. For creating an array of characters, just like any other array, I will take an array name as X, and this is an array. Mention the size. So array of size 5 characters will be created. Now, can I initialize this one? Yes. So I will take the same name here. I will not change the name. So I can set the name as X and size is 5. And if I want to initialize, I can give alphabets. This is declaration plus initialization. So an array will be created with a name X, and it will have alphabets A, B, C, D, E. Actually, their ASCII codes will be present in that array. Then, third method, I can create an array without giving any size. So, A, B. So, same type of array will be created of size 5 and initialized with all these alphabets. I have not mentioned the size. Size will be taken depending on the number of alphabets I am assigning. And one more method, I can create an array by either mentioning or not mentioning the size. I will write 65, 66. So these are the ASCII codes for these alphabets. So the same thing will appear, same thing, same array will be created, because 65 is for capital letter A and 66 for B and so on. So same array will be created. So all these three methods, same array will be created. Now I will create one more array. I'll create an array char of size 5, and I will mention only 2 alphabets, right? So now the array that is created, only alphabet A, B are stored. So these are all zeros, initialized with 0. So the set of characters are till here only, but the array size is total 5. I have only 2 alphabets. So yes, it is possible. So then I should know till where I have kept the characters. So it is just like a normal integer array. Array size may be 100, but you are having only 15 elements or 10 elements in that. So same as that one, array of characters of size 5, but I have only 2 valid alphabets. Rest of the places are empty, vacant, not in use. This is possible. Now next I will carry on with the same example here, and I will explain you what are strings. I want to store a name in an array. So I will create an array of characters. Then let us call the array name as name, and let us give it as size as 10, and here I will store name. Name is John. Array of size 10 is created, and in that John is stored. So John, only 4 alphabets. Rest of them are all zeros. Yes, this is character array or array of characters. Array of characters, right? So this is array of characters having name John. So array of characters is nothing but a string, right? It's a string. For storing names, for storing the words or sentences or paras, we need string, right? It is nothing but set of characters. So string is nothing but a set of characters basically. So a name is a string. But now the problem, let us understand more about string. See here, the size of an array is 10, but the string size is only 4 alphabets. Then how do I know where this string is ending? So that is the important thing. When the size of an array may be larger, but you are having only part of it as a string, then we need to know till where we have a string. So we should know either the length of a string, or we should have the end point of a string. So yes, in C and C++, it is marked with null character, that is /0. This /0. This is a null symbol or a string delimiter or end of the string character. It is called as string delimiter or end of the string character or null character, or also we call it as string terminator, right? So that's it. This is used to show the end of a string, end of string marker. So in C++, strings are delimited with null character, that is /0. But whereas in other language like Java, strings will not have /0. Then how to know how many alphabets are valid? So that is known with the help of length. So this is length. Length is how much? 4. So in Java, string length is known, or the size of a string is known by its length, but in C++, the size of a string is known by finding a termination character, that is null character. So strings are delimited by /0. Now this is just an array of characters. How to make it as a string? In C++, I must write /0 also. So take a quote and /0 and close the quotes. So this is within quotes. So John terminated by /0. So this becomes a string now. Without this, it is just an array of characters. By adding /0, it becomes a string. So that's the difference between an array of characters and a string. When you have words or names of things or places, then you can take it as a string. Now let us see what are the methods of creating or declaring a string and also initializing it. So let us see the methods. See, this is the first method for declaring as well as initializing a string. Second thing, I can declare a string without size and I will use same name. This is another way. Just the difference is I have not given the size. Then what will be the size of this array? 1, 2, 3, 4, 5. The size of an array is 5. So for storing 4 alphabets of a word or a name, I must take 5 spaces, so that I should provide a space for /0 also. So /0 also consumes space. Then next method of declaring or initializing a string. Say name. Now the same, as it is a string, I can write down in double quotes. So yes. So only John is written as it is in double quotes. So /0 will be automatically included. C compiler will take care of it. So we don't have to mention /0. So then this looks better than these two methods. Yes, strings are enclosed in double quotes, right? Then next, one more method of creating a string. This is a character pointer. Yes, this is a character pointer. Then where this string will be created? Now the speciality of this one is this string will be automatically created in heap. Though we did not use a malloc function or we did not write a new, but this is implicitly allocated in heap. Then where these arrays are created? All these arrays are created inside the stack. So what does it mean? We have already seen this memory structure, right? So here the program will be there, the code will be there, and this is the stack and this is heap, right? So this is stack and heap. Now if I take all these arrays, all those arrays are created here. They are created like this. If I take the example of this one, then what about this? I'll just change the name. I'll make it as just n, and this is inside heap, right? So I have changed the name n. Now if you look at this one, then this is n and this string is created inside heap along with the /0 and n is pointing there. So n is a character pointer pointing on this string. So this is the difference. So if you create these are all created inside the stack, right? Which is directly accessible to a program. This is created in heap. So this is indirectly accessible using a pointer. So this is created in heap. So automatic compiler will create this string inside heap and pointer will point there. Now let me talk about printf and cout or scanf, little bit about this one. So to learn how to display this string and how that printf works. This is a string. I am taking this string. The array size is 10 and it is having a string of size 4 and including /0 is also there. Then if I use printf, say printf I want to print this entire string, that is whole name, complete name. So say S. So this control character S is for string, percentile S. Then here I should just mention name. So that is name of an array. Yes, you can just give the name of an array, a string will be displayed. So it is not possible for any other type of array. Remember this, it's not for integer or float, like just you are giving the name and it is displaying the entire array. No. Here printf knows till where it has to print the alphabets, because it will be gone printing the alphabets on the screen until it finds /0, right? So this will print this complete name and it will stop when it reaches /0. So how it will do? It will print first J, then O, then H, then N, then /0, it will stop, right? So that's how printf works. Then if suppose I want to read some new name, another name in this one, so I can use scanf. Now scanf percentile S again, so that is for reading a string, and give the name of an array. Yes, scanf can also read a string from the keyboard and store those alphabets there, followed by /0. So printf and scanf both are dependent on that /0. So all the library functions of C language that are meant for strings are dependent on /0, that is null character. They work upon string till they find /0. So this is scanf. If you type something from the keyboard, like if you're typing David, then David will be stored here like this. Then followed by that, it will add /0. Thus scanf will store /0 by itself, right? So we don't have to type /0 also from the keyboard. Just you type David like this and hit enter. It will store that. Then similarly, scene and cout also works in the same way upon a string, that is character array with a /0. Now one last thing. This is scanf. Now one more last thing. This scanf is useful for reading just one word string. If you have multiple words, it cannot read them. If you are writing a string, like suppose you are writing Taj Mahal, right? Then there is a space in between. So if you type this, then scanf will just take first word. It will skip the second word. It cannot take the remaining words. So if you want to read all the words till you hit enter, right? Till you hit enter, then you can use a function called getS and give the array name. So get string or getS is a function for reading an entire string until you hit enter. So the problem of scanf can be overcome with getS. So that's all about the string. So we have learned about ASCII codes and the representation of string. We have learned about the null characters. Then in the coming videos, we'll look on operations upon strings, various operations we will discuss. In the previous video, already we have got the introduction of a string. Now in this section, we will be writing functions upon string. So commonly used functions we will write, and most of these functions are available as library functions or the class members in C and C++. So we will learn how these functions work so that if required, we can develop our own logic for performing any operation which is not available. So let us start with the first operation, that is finding the length of a string. So already I have an example string here. We want to find out length. Length means the number of characters present in a string. So for finding the number of characters in this array or a string, we have to count all the characters until we reach /0. Like 0, 1, 2, 3, 4, 5, 6, at 7 we got /0, means there are total 7 characters. The length of a string is 7. 1, 2, 3, 4, 5, 6, 7. There are 7 alphabets, right? As the indices are starting from 0 onwards, so at 7 we have /0. So this is how we count. If I raise a question, why don't we know the length of an array? Array size is 8, right? 0 to 7, 8 minus 1 is the size of a string. But already in the previous video I said that the length of an array can be anything. The size of an array can be bigger than the size of a string. So how do we know till where we have a string? So we identify it by /0. So yes, the method for finding a length of a string is we have to find /0. So let us take, so the procedure is very simple. Just we have to scan through this array of characters until we reach /0. So we have to traverse this one. So for that, we can take a integer pointer I and we can go on looking at the character for /0. Is it /0? No. Then move to the next. Is it /0? Is it /0? No. Yes, we got a /0, that is null character. So stop there. So till at whichever index we have stopped, that is the length of a string. That's it. So I will write on the piece of program code, and this finding the length logic is very important. We perform all other operations in a similar way. So let us write on a main function directly. I will write on here. Here first I will create a string. Char, string name is S. So I will take a pointer and I will write a string that is welcome. No need of /0 because it is enclosed in double quotes. So C language or C++ compiler will create this as this type of array along with /0. It will fill that null character. Now I have to scan through this. So for that I may need a variable that is I. Then using a for loop I can scan through this. So for I assign 0 and every time I plus plus. But how long I should continue? When I should stop? When this S of I or S of I is /0, that is null character, I should stop. So if it is not equal to null character, I should continue. So here the condition should be S of I not equal to null character. That's it. So this for loop will start from 0 and go on incrementing, and it will stop when it has reached this null character. So this is the for loop. Now what I have to do in this one? I don't have to do anything. It is empty because just I am finding length. Yes. So it has to remain empty only. Now once we come out of this for loop, the value of I will show the length of a string. So where I will be stopping, it will be stopping here. So what is the value here, index here? I value is 7. So length of a string is 7. So here I will printf. So printf length is %di. So I is the length of a string. That's all. This is the end of the main function. So I can write return 0 and stop. This is the code or a function for finding the length of a string. That's it. I will not give a demo for this one. So this is a student exercise. You have to do it by yourself. You write down this code and test it. In C or C++, anywhere you can write on this piece of code and check it. That's all. So similarly, we will look at other simple operations on string in coming videos. In this video, we will see how to change the case of alphabets, that is cases from lowercase to uppercase, uppercase to lowercase of characters in a string. So here I have an example. I have a string that is welcome. This is all in capital letters or upper cases. I want to change those alphabets to lower cases. So how it is possible? Let us see. See, already we have seen the ASCII codes for alphabets. Capital A ASCII code is 65 and B's ASCII code is 66 and so on. And capital Z ASCII code is 90. Similarly, we have seen ASCII codes for lower cases also, that is 97 and this is 98 and so on up to lowercase z is 122. We know these cases. So it means when it is capital W, I have to change it to lowercase w. So if suppose it is uppercase A, I want to convert into lowercase a. So how it is possible? So actually the code is there, that is 65. This is 97. What is the difference? 97 minus 65 is 32. This is the difference. What about the difference between these two alphabets? 98 minus 66 is again 32. Oh, so it means that uppercase and lowercase letters difference is 32. Yes. So it means, so similarly, capital Z and a small letter z, if I take, that is 122 minus 90 is 32. So yes, so it means that the difference between uppercase to lowercase is of 32. If it is uppercase, in that if I add 32, then I'll get a lowercase ASCII code. So is it possible to add numbers to alphabets? Yes, actually the alphabets or letters are nothing but codes. They are numeric codes, right? For a programmer or for the user, it is visible as W, but actually it is ASCII code inside the main memory. So yes, I can modify it by adding some number. So how to convert from uppercase to lowercase? Add 32. Let us give it a try. I will add 32 in all these alphabets starting from index 0 onwards. So these are the indices, right? Starting from index 0 up to the end of a string, I will add 32 all of them, as already those are in upper cases. So already you should know what is the present case. Then you can change the cases. So let me write on the procedure for converting the cases. I should scan through all these alphabets. So for that I need a for loop. So I will declare a variable I. So for I assign 0, and I should stop when it is /0. I have given the name of a string as A. So as long as A of I is not equal to null character, I should increment A. Then what I should do every time? Every time at each place, here I should add 32. So at A of I should add A of I plus 32. So 32 code is added, so it will become a lowercase. Then after finishing this, I will print the string. So printf %s, I will print a string A. That's it. I can get a display of lowercase alphabets for a string welcome. We have already seen how to scan through a string or how to traverse a string using a for loop. We have already seen in the previous videos. So I'm scanning through, and while going through all the characters, only thing I am doing is adding 32, so it is becoming lowercase. So similarly, if I subtract 32, it will become uppercase if the string was already in lower cases. So yes, you can change the case by adding or subtracting 32. Now next thing I'll show you how to toggle the cases. Toggle the case means if it is lowercase, I'll change it to uppercase. If it is upper, I will change it to lowercase. So let us look at how to toggle the cases of alphabets in a string. I have these alphabets, some are in lower cases and some are in upper cases, like E and C are in uppercase, rest of them are in lower cases. So whichever are in lower case, I will change them into uppercase and uppercase to lowercase. So it is simple. If it is upper, I have to add 32. If it is lower, I have to subtract 32. So for that, I should scan through this whole string. So for scanning through a string, I need a for loop. Already I have a for loop. Now in this string, inside this for loop, I will modify the alphabets. So here what I have to do, check if it is uppercase. So first check if it is uppercase. So I can write a condition here that if A of I is, when it is uppercase, from 65 to 90. If A of I is greater than or equal to, I can write 65, and A of I is less than or equal to 90. So this means it is uppercase. So change it to lowercase. By adding 32, I can change it to lowercase. So for addition, I can use this symbol also, that is assignment addition operation, and I will add 32. If it is not uppercase, else. Check if it is lowercase. If it is lowercase, then change it to upper by subtracting 32. So I should not simply write else, I should check the condition that if it is lowercase. So when it is lowercase, if it is in between 97 to 122, so greater than or equal to 97. So instead of writing 97, I can write alphabet also in single quotes. So it is 97, and A of I is less than or equal to 122. If so, then I should change this by subtracting 32. Yes, this loop will toggle the cases. If it is uppercase, lowercase, but don't change it again. If it is not uppercase, check if it is lowercase and change the case. Now one more important thing in this one is that if there are other symbols other than alphabets, they will be untouched. They will not be modified. Like suppose here instead of E, I have letter symbol 5. That is 5. So it remains 5 only. It will not be changed. So if it is 5, then it remains 5 only because it doesn't come under this range or this range. At last, I should print this string. So I will simply write printf here. So you know very well how to print. I will write just pfa. So you know the syntax. So that's all. I have shown you two things here, how to change uppercase to lowercase and toggling cases. And lowercase to uppercase, you can write it. So all these programs you have to write down on your own machine. These are all simple programs. Simply inside a main function, you can try this program by yourself. So this is a practice program or a student challenge. You have to do it by yourself. So we will see more functions or more operations on string in coming videos. In this video, we will see a few more operations on string, like counting number of words in a sentence. Suppose a string is a single sentence, we want to know how many words are there. And also we want to count the number of vowels or number of consonants in a string. So first let me show you vowels and consonants. Here already I have a string, that is how are you, right? So in this string, how many vowels are there? I want to find out. See, the vowels are O, A, E, O, U. So 1, 2, 3, 4, 5. 5 vowels are there, remaining are consonants. So if I draw that string here, so here I have taken a string in the form of an array. Now counting vowels. So what are vowels? A, E, I, O, U. So A, E, I, O, U. If it is an alphabet, is an A, E, I, O, U, then it is a vowel. So I will take a counter here and if any alphabet is a vowel, I will increment the counter. So for that, I have to scan through this string. So already I have some program code here. So here I will write on the code for counting vowels. Let us see. I will take one variable, that is v count. I will call it as vowel counter, right? And let it be initially 0. Now, while scanning through this string from 0th alphabet, that is first position to the last position, I should check if it is a vowel. So how to check whether it is A or E or I or O, U then? Also, it is uppercase and lowercase. So I have to write so many conditions. So I will write few here, like if A of I is equal to lowercase a, or if A of I is equal to lowercase e. Same way I should write for all. Then in between these two conditions I am using or. So be careful of this one. So or means it's A or E or I, right? So up to you can write in capitals, and for capital letter also I should take it, right? Capital A or E or so on. So this is for lower cases and upper cases. So many conditions I have to write. So definitely I have to write all those things. So it can be any one of those alphabets. So either lowercase or uppercase. If this condition is true, then I should take v count plus plus. So count that alphabet by incrementing the counter. So that's all. So at the end of this for loop, if I print the value of v count, I'll get the number of vowels present in a string. This is one thing. The next, suppose I want to count consonants also. Then inside the same program, I can include one more counter, that is for consonants. So C count, that is consonants, I will initialize to 0. Then here, if it is not a vowel, then it may be a consonant, but it must be within the range of alphabets. Otherwise, see, if it is not a vowel, right? This is not a vowel, this is a vowel, this is not a vowel. This is not a vowel, so spaces will also be counted. So I should not take any special characters or spaces, I should take only alphabets. So make sure that it is within the range of alphabets. So here I will continue writing else, if. I should make sure that it is within the range. So A of I should be greater than or equal to 65 and A of I should be less than or equal to 90, right? It should be within this range. Or this is for capital letters, or it should be in lowercase. So again, I should continue here, no space, so I will write on here. So A of I should be greater than or equal to 97 and A of I should be less than or equal to 122. So it should be 122. So if it is within this range, that is either lowercase or uppercase. See, already we have checked it is not among A, E, I, O, U. Then other than that, all other characters are within that range only. So I should check this range. If so, then I will say C count, that is consonant count, plus plus. Then after the end of the for loop, you know very well that you have to print the value of that is vowel counter and consonant counter. So this is how you can count vowels and consonants. Now next let us see how to count number of words in a string. Now let us see how to count words. See, in this string how many words are there? 1, 2, 3. 3 words are there. So how do you know there are 3 words? Because there are 2 spaces, 1, 2. So it means spaces will help us identify words. So yes, so what is the method? Simply count the spaces, as many spaces plus 1 words are there. So we know very well how to scan through a string and just we have to check for the spaces. So I will write on the code here. This for loop will take me through the entire string. Then every time I check that if A of I, if it is equal to a space. If it is space, then word plus plus. So already I have taken a variable called word, and that word plus plus, it will count the number of spaces. And after this for loop, I can printf percentile d, that is number of words that we are finding out. So that should be word plus 1, because word has given me number of spaces. Actually I have counted spaces. Then that plus 1 will give me number of words. Or else if you don't want to add it afterwards, then you can start from 1 here. Now as many spaces we have, that many times this word will increment. So there are 2 spaces, so 2 times it will increment. Already 1 we have. So total 3 words are there. Now one more thing in this one. If suppose more than 1 spaces are there, how it is possible? See, how space or space, suppose this is not there, then U is there. So there are 3 spaces, then U. So if that U, I count it as a word, then total how many words are there? Only 3 words are there. But in my program, if I count the spaces, 1, 2, 3, 4, and plus 1 I am doing. So 5 words are there. So that is wrong. Then how to deal with these excess spaces? So when you have continuous set of spaces, it is actually called as white space. It's called as white space. So if there are any white spaces, I should check that also. So let us see how to do that. See, this is 1 space I have counted. This is 1 space I have counted. Next space, don't count it. So how to know that this space should be counted or not counted? Because the previous one was also a space, right? Then what about this one? Previous one was a space, don't count it. So whenever you are having a space, check that previous one is also a space. If so, then count it. So let us do it once again. This is space, previous one is not a space. This is space, previous one is not a space, so count it. This one, previous one is space, don't count. Previous one space, don't count. So here, along with this condition, I should check that if A of I is equal to space and A of I minus 1, that is previous alphabet, should not be a space, right? It's not a space. If so, then word plus plus. So extra condition, so it will take care of white spaces also. That's it, then print the number of words here. So this is the procedure for considering white spaces also. So we have seen counting vowels, consonants and the number of words in a string. This is a simple exercise, simplest thing, but I have explained it. So you can do this one by yourself. So you have to write this program as a student exercise. So try it on your PC. That's all, try this program. We will see more operations on string in coming videos. Now in this video we will learn how to validate a string, whether a given string is valid or not. Most of the time while creating a login or an account, we have to mention a username or password. And for most passwords, we find that a valid password is required. So what is valid password? Only alphabets or numbers are allowed, special characters are not allowed. So similar thing we are going to check it. So we have a string here. Now in this string, only alphabets and numbers are there. So it is a valid string. If any special character is there, then it is invalid. For example, I will change one of the alphabet. I'll make it as a question mark. Like this is a special character. So if it is a special character, then it is invalid string. Right? So this is what we have to check whether it is valid or not. So there are two methods. One is a simple method that I am going to show you. Second method is using regular expressions. So if you want to learn about regular expression, you can learn and use it. Even in C++ programs, you can use that. Now let us follow the basic method. So in this method, what I should do to check whether it is valid or not, I should scan through this entire string and find each and every alphabet is valid or not. If any one of the alphabet is not valid, then I should say it is invalid string. Like first A, yes, it's capital A, it's okay. Then N, okay. I, okay. Question mark, invalid. So stop, I don't have to check the rest. If suppose this was valid, it was L earlier, so it's valid, 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 valid. Reach the end, so true, its string is valid string, right? So for performing this procedure, I should scan through the string and check for each and every alphabet. So let us write on a function for that one. Instead of writing inside the main function, I will write it as a function. So let us check it. I'll change it to question mark. It is invalid, right? So I'll write a function name is valid, right? And it will take a string as a parameter, so character and star name. So that will appear here, and it should return whether it is true or false, means valid or not. So if it is valid, it will return 1, otherwise it will return 0. Then what I have to do in this one, I should scan through this string. So for that I will take a variable I, and using a for loop I will scan through this. For I assign 0, and as long as name of I is not equal to null character, continue I++. Then each time I should check whether an alphabet is valid or not. So for being valid, it should be within a range of capital letters, small letters or numbers. If it is not, then it is invalid. So here I will write on the conditions, just watch the condition. If name of I is greater than or equal to 65 and name of I is less than equal to 90. So what is this? This is for valid range. Yes, it is valid range, valid uppercases. But I have to check for invalid. So instead of taking this, I should say not of this, means it is not in this one. If it is not in this one, if it is not in this one, then it is invalid, right? But other ranges are also there, lower cases are also there. So I should write, and I should check for the next set of characters, that is small letters. Then again, not of small letter, that is name of I is greater than or equal to 97 and name of I is less than or equal to 122, and means it is not in this range and not in this range and not in another range. So it means it's not in this range and not this in this range, as well as for numbers also I should write down. So I will not complete this one. So again I have to say name of, that is 48 to 57, right? You can understand this one. So these three conditions, if it is not among these, then it's a special character. So here I should return false, that is 0. And this is all happening inside for loop, right? Inside the for loop, for every alphabet we are checking whether it is not in this range and not in this range and not in this range, then it is a invalid symbol, right? Invalid letter. So return 0 means return false. Otherwise, if I have came out of the loop by reaching the end of a string, then everything was perfect. So return 1, return true. That's it. So this is the validation function. Now there inside the main function, I will write down if validate send name. If it returns true, if this returns true, then this if will be true. Then we will print, just I'll write pf here for printing. Then I will say valid string or valid string, right? Then otherwise in the else part, I will write printf, that is just I am saying pf, so it is invalid string. Means if it is false, then it is invalid string. This is the main function. So in this function, we have written a lot of conditions. So yes, if a lot of rules are there, then a lot of conditions will be there. So we have seen a validation function. You can try this function. You can write down this function by yourself. Now the topic is reversing a string. So for reversing a string, already I have taken an example. A string is there. It is Python is written in that string. I want to reverse it. So for reversing, there are more than one method. So I will show you a first method for reversing a string. Now in first method, we will take another array and copy the reverse form of that original string in this array. So that will remain as it is, and we will get the reverse version of that string in another array. So this array, character array, will make it as a string. So the difference is that /0 we will add it at the end. So it becomes a string. So let us see how we can reverse it. So for reversing, I should first of all reach at the end of a string, that is at the last alphabet. So once I reach there, I can start copying those elements in this array in reverse. So first I will copy N, then O, then H. In this way, I can copy all these alphabets and at the end add /0. So it is just like reverse copying a string. So first of all, I should reach till the end of a string. So let us do that. I will take I as a index upon an array, and I will go on moving this I until I reach /0. So we know very well how to do this. I'll take some variable I, and for I assign 0 and a of I is not equal to /0 I plus plus. No need of anything inside, just empty brackets. So this I will be stopping at last null character. Now I should start copying the elements from this place, that is I minus 1 onwards, from this place onwards. So okay, I assign I minus 1. I is reduced one step. Now I should copy those elements here. N should be copied here. So for this I should have J also here, right? So now N I will copy, then decrement I, increment J. Then O I will copy, decrement I and increment J. Then H I will copy here, then decrement I and increment J. In this way I will copy T, then Y, then at last when it has P here, then copy P, right? Decrement I, so I becomes -1 and increment J. Now stop, because we have finished all the alphabets. How do you say that? Because I has become -1. So the same thing I will write down here. So I need one more thing, that is J, that should start from 0 onwards. And how long I should continue? As long as I is greater than or equal to 0. And every time I should do I minus minus, comma, J plus plus. Then what I was doing, copying an alphabet from array A to array B, array A to array B, right? So inside B of J, I should copy A of I. See, initially when I was here, if you look at this, J was here, copy the element of A of I in B of J. So B of J assign A of I. So after finish copying all the elements, when the J has reached here, I should add /0 here in B. So after the for loop, once I have finished everything, then B of J should be assigned with /0. Now this becomes a string. It was array of characters. Now along with the slash 0 it has become a string. Now I can print this reverse form of this string. So simply say printf percentile s b. This will print a reverse form of a string. So this is first method. In this method, we have reverse copied a string in another array. That's all. So you can try this program. You can take a string and one more character array and you can write on this code and check it by yourself. Now second method, I will show you how to reverse a string using second method. So I'll remove this and I'll explain you. Now let us look at the second method for reversing a string. In this method, we don't require any extra array. Same string we will modify. And one more thing you should know that in some C++ compilers, means the recent compilers, latest compilers, strings are not mutable. They cannot be changed. Instead of array, if you take it as a pointer, then those strings cannot be modified. So make sure that you are taking a mutable string. So in C++, declare a string with array of characters. So make it as array. Then it is mutable. So we will modify the same string. Now let us come to the procedure. How to do this one? So the procedure is, we will exchange the characters, so swap the characters of a string, the first letter with the last letter and the second letter with the second last letter and this letter. In this way we will exchange the characters of a string, right? So for that we have to scan from the left hand side as well as from the right hand side. So for scanning we should know the length to start from the right hand side. So already we know how to find the length. So this is the code I have written. Already I is there, so I have used and making it stand here. So let us do one thing. Instead of I'll just make it as j, right? So let us say this is j. J is pointing at the last position, that is at null character. Now from here I will use I, and let us exchange the characters from starting from this character onwards, right? As long as I is less than j. Once they meet or once they cross each other, let us stop. So let us do this and write on the code for that one. So j should start from one step less. So let us decrement j assign j minus 1. Now j is here. So using a for loop, we can make them move and copy the element. So let us say n comes here and the p goes there. So we have to swap the alphabets. So this can be done in a for loop. For I starts from 0 as long as I is less than j and I is plus plus and j is minus minus. So we have to increment I and decrement j. And each time what we should do, interchange the characters from there. So for swapping, I need some variable. So let us take a character type variable t, and with the help of this t we will exchange. A of I value is exchanged with A of j. So first of all take it in t, then A of I assign A of j, right? Then A of j assign with t. So this for loop will exchange the two alphabets and move I, increment I and decrement j. So let us do it. Next I will increment and j will decrement. So O comes here, Y goes there. Then I increments and j decrements. So interchange this. H comes here and t goes there. Then I increments and j decrements. Now stop, because I has become greater than j. So this will continue as long as I is less than j. Then I don't have to write /0, it's already there. We have not disturbed it. It is in its own place. So simply if I print this one, I get a reverse string. Printf percentile s, that is a. That's it. See, we have not used this another array, so I will remove that. We have used just t as a character. So this is the method for reversing a string without using another array. So we have seen two methods. Even this method is a student exercise, so you have to write down this code and try it. That's all in this video. We'll look at few more operations on string in next videos. In this video we will learn how to compare two strings, as well as I'll explain you what does it mean by palindrome and also explain you how to find whether a string is a palindrome or not. So first let us look at how to compare two strings. So for example, I have taken two strings here, like one is painter and another one is painting. So if you look at these strings, P-A-I-N-T, till here they are equal, and here E and I, they are different. So that's what we need a method to know whether these are same or different, whether two strings are same or different. So let us see how to compare them, then I will show you what should be the result. Let us start. For comparing them, I should scan one letter at a time from both the strings. So I will take I here and J here. Now using this first I and J, I will check first alphabet. Yes, it is same. Both are capital P. Yes, exactly same. Then next, move I and move J. These are also same. So in this way, I should move ahead if they are same, right? So these are same. Then compare with N, they are same. T, they are same. Then I moves here and J moves here. Then here if you see, it is E, but it is I. So they are not matching. So no need to continue further. If any one alphabet at corresponding locations it's not matching, then two strings are not same. Yes. Then answer is they are not equal. Okay. But we can also tell which string comes first in dictionary, which comes next. So the one comes first in the dictionary is a smaller string, one comes next is a greater string. So if you check this, which comes first? E comes first. E comes before I. So the ASCII code of E is less than ASCII code of I. So we can say that this string is smaller than this one, right? So even this can be greater than this one also, right? In our example, this is smaller. So here we can compare two strings and the result is whether they are equal or the first one is smaller or first one is greater. Now one more thing. See, this was the example where the strings were not matching. If they match, then what happens? If they are matching, then what happens? Let me change the string and show you. See, instead of this is painting, this is suppose it is painter. It is painter. Then definitely we'll have /0, right? So let me continue. I here, I, J here, both are equal. Yes, continue. Right? Both are equal. Yes, continue. I will increment and J will also increment. Now we should stop. Why we should stop? Because we have reached /0, right? We have reached /0. We should stop our procedure if we have reached /0, and if both are at /0 means they are matching because they are equal. /0, yes, they are equal. Now earlier I was pointing here and J was pointing here, right? So these are not equal, so we will stop here, and this is painting /0. They are not equal, so we should stop and check. They are not equal. Yes, they are not equal. Then first one is smaller than this one, so we should say first one is smaller. If suppose you have a bigger alphabet here, then say first one is greater. That's all. So the procedure will go on comparing the alphabets one by one, and when it will stop, there are two situations. If a mismatch is found, it will stop, or any one of the string is ending, it will stop. So the procedure is very simple. I will quickly write down the procedure here. I need I as well as J. Then using a for loop, I can start I also from 0 and J also from 0 because both we are starting from here. And how long I should continue? Unless any one of the string is ending. Any one of the string ends, I should stop. So here I should say that A of I is not equal to /0, that is null character, and B of J is not equal to null character. Then no space, so here I will continue. After that, I should increment I as well as increment J. Increment both I and J. That's it. Now inside the loop, what I should do? I should check if they are matching or not. If they are matching, I don't have to do anything. If they are not matching, then I should stop the procedure. So this loop, if A of I is not equal to B of J, then simply stop from this for loop and say break. Come out of this. That's it. Then after coming out of the loop, I should see that whether they are equal wherever I and j are pointing, or first one is greater or first one is smaller. Based on that, I should display a message. So here I will write down the code for that one. See here, if a of I is equal to b of j, print equal. Else, if a of I is less than b of j, then say that first string is smaller, it comes first in a dictionary. So a of I is smaller. So I will simply say smaller because we are comparing the first one with second one. So I will simply say smaller. Else I will say greater. So it means the first string is greater. So this is the procedure. Just using a for loop. See, almost all the procedures on string are just using a for loop. Within a for loop, we have scanned through the entire string. That depends on the length of the string, right? And while scanning through, either we are counting or we are displaying or we are changing the cases or we are comparing. All these things we can do. For that, we have to scan through a string once. So this is the program. Now I have to show you one more thing. See, what if this is small letter p and this is capital letter P? If I compare I and j, then the ASCII codes for this small letter and capital letter are different. ASCII codes for small letter are higher. Then this is your choice. Do you want to say that P is just P? Yes. So it means independent of their cases you want to check, so you can check it. So how to do that? First of all, you should know the case of an alphabet. It's a lower case and this upper case, right? So you change them into any one of the case, both in lower case or both in upper case. Then compare them. This is what you can do if you want to check them by ignoring their cases, right? Otherwise, the procedure what we wrote, it will stop here only. It will not check next character because this is greater than this one, because capital P comes first in ASCII codes and small letter p comes next. So this string will be smaller and that will be greater, right? Depending on the cases of alphabets. So this is how the strings are compared. Now next I will show you what is palindrome and how to check whether a string is a palindrome or not. Let us know what is a palindrome. A string is said to be a palindrome if you reverse the string, it remains same. For example, I have a string here that is madam. If I reverse it, so first write M, then A, then D, then A, then M. So I have taken M, A, D, A, M, madam. So again it has formed the same thing. So if you reverse a string and if it remains the same, then it is a palindrome. I will show you few more strings which are palindrome, like little. If you reverse it, it is little only. Or Nitin, if you reverse it, it is a palindrome. So it's the same thing, Nitin only. This is Aza. If you reverse it, it's Aza. So these are all palindromes. So our problem is, if a string is given, then we have to find out whether it's a palindrome or not. So what is the procedure? See, the procedure is simple. Now we already know few things. So the procedure becomes simple for us. First of all, you reverse copy a string. So if you have a string in an array, then reverse copy it in another array. We have already seen it in previous video how to reverse copy a string. Then after reverse copying a string, you have to compare two strings, right? Compare two strings. Till you reach /0, they will be same only because it's a reverse of a same string and it is a palindrome. So if they are equal, then it is a palindrome. So we have already seen how to compare two strings and how to know whether they are equal or first one is greater or smaller. So we don't want greater or smaller, we want whether they are equal or not. So if they are equal, then it's a palindrome. So you take an array A and take an array B. In B you copy these elements from A in reverse copy it, then compare them. So reverse and compare. Reverse first step and second is compare. Now one more thing. So this is one method I have shown you. Now is there any way other possible? Yes. How? you can compare the strings, same strings. You don't need another array. Same strings start from here and here. Compare, they are equal. So increment and decrement, they are equal. Increment and decrement, this is same only. So stop. If anywhere it doesn't match, then say that it is not a palindrome. So without taking another array, you can compare the same string from the last, right? So it was just like reverse. In reversing, we have done it. We have instead of swapping, you have to check whether the alphabets are same or not. So with the second method, without any extra array, you can find out whether it's a palindrome or not. So here, even I am not writing the code how to do that, because we have already seen these two things. So you write down by taking extra array or without taking extra array, both the programs you write down as a student challenge. Now the topic is finding duplicates in a string. Here is a string. We have to find out, are there any duplicate alphabets in a string. For example, in a given string, I is repeating more than one time, N is repeating more than one time. So we have to find out, are there any alphabets which are repeating more than one time. So this is same as finding duplicate elements in a array of integers, which we have already seen in the topic arrays. So the same thing, it is for string, that is alphabets we have to check. So there are more than one methods for finding duplicates. We have already seen multiple methods for finding duplicate numbers. Now we will see what are the methods for finding duplicate characters in a string. See, the first method is comparing with other letters. Then second one is using hash table or counting the letters. Then the third one is using bits. Now this method, the first method, is same as what we have learned in arrays, like taking a number and comparing with rest of the numbers in an array. So we will take an alphabet and compare with rest of the alphabets in an array. So the method is same. So I will not explain you in detail. You can refer back to the video finding duplicate elements in an array of integers. Then second method is also similar to the one we have already seen, but there is a little change here. So I will explain this one. Then the third one is the new one, that is using bits, that I will cover in next video. So let us start with the first method, comparing with other elements. Let us see comparing an alphabet with the rest of the alphabets. So the procedure is, we will start scanning the string from left hand side. Let us start from here. First, F. Now we have to check, is there any other F inside a string? If so, we have to count it. So we can take a help of J counter and start checking. Is it F? No. Next character, is it F? No. Is it F? No. Is it equal to this? No. Is this equal to this? No. Is it equal to this? No. We have reached the end. So we have scanned through the rest of the characters in a string. Then F is not found. Next we will move to the next character. Is it same as I? No. Is it same as I? This one? No. Is it same? Yes, it is found. So we found one duplicate. So as I already told you that we should remove this and make it as 0 so that it should not be counted once again. Right? Then check with this one. No. Check it with this one. No. We have reached the end. So we have found one more I. So there are two occurrences of I, this one and the another one that we found. So the similar procedure you can follow. You can check the video once again for finding duplicate elements in an array. Like this method I have shown you. So it's the same method. Only thing is here the alphabets are there and you have to stop when you are reaching null character. Right? And we have also done the analysis for that one. The time taken is order of n square, that is big O of n square. So the same thing, same analysis, same procedure, only these are alphabets, right? So I don't want to elaborate this one. Now let us go to the second method, that is using hash table or counting the occurrences of alphabets. So let us look at hash table. For using hash table, we should have an array to work as an hash table. Now what should be the size of an array? That depends on the numbers that we are storing. So whatever the largest number that we are storing, we need an array of that much size. Yes. So let us see what we are actually going to store. See, we are going to store alphabets and these alphabets are having their ASCII codes. Yes, ASCII code. I have taken all these alphabets as lower cases. So they are in the range of lowercase alphabets. So we should know the ASCII code of all these alphabets. So let me write down ASCII codes. See, ASCII code of D is 100 and F is 102, G is 103, I is 105 and N is 110. These are the ASCII codes. So ASCII codes are more than 100, right? So if you know the range of lower cases, the lowercase range starts from 97 to 122. So it means I need an array up to the maximum length of 122, and I will be start using that array from 97 onwards. Means all the elements from 0 to 96 are useless. Why to create that much lengthy array when we know that the first letter lowercase a is 97 and lowercase z is 122? So why can't we call this as a 0, right, and the b as 1 and so on? So this will be 25. So 0 to 25, total 26. So it means an array of size 25 will be sufficient for us. Yes, array of 25 is sufficient. So this is how we can reduce the size of the hash table. We can take just of size 26, that is 0 to 25, and we can find out the counting of these alphabets and the duplicates alphabets, right? And mind it, this is only for lowercase alphabets. There are no uppercases. So let us draw a hash table and run the procedure and see how we can count them. So here I have an array for hash table, that is starting index is 0 and the ending index is 25. So I have an array of size 26. Now let us run the procedure and scan through the string. Now one more thing, this array, assume that it is filled with zeros, right? I did not fill it with 0 to make it just simple, to look simple. I have left them empty. Assume that are all zeros. All right. Now let us scan through this string. First alphabet F. ASCII code of F is 102, right? Minus 97 if we do. This is 5. So go to the index 5 and already it is 0, just increment it. So it is 1. Then move to the next alphabet I. This is 105. So I is 105. Minus 97 if you do, then this will be 8. So go to index 8 and increment it. So already it was 0, just make it as 1 plus 1. Then next N. N ASCII code is 110, right? Subtract 97, so it is 13. Go to index 13 and increment it. Then move to the next alphabet, that is a D. D's ASCII code is 100. Minus 97 gives 3. Go to index 3 and increment it. Then next is I. I's ASCII code is 105. Minus 97, 8. Go to index 8 and increment. So this was already 1, so it will become 2. The next N. 13. Go to 13. It's already 1. Make it 2. Then next is G. G ASCII code is 103 minus 97. So this is 6. Go to index 6 and increment it. Then next is null. So that's all. We have finished the string. Now we have the counting of all the alphabets. See, first is representing 0. 0 means 0 plus 97, right? 0 plus 97, because we have subtracted 97. Now add 97 to this one. 97, A is 0 times. Then plus 1, 98. B is 0 times. C is also 0 time. D is 1 time. Likewise, we know the counting of each and every alphabet in a string. So if you want to know what is this one, so add 97 to this. 97 plus 8. So this is 103, and 103 is G. So that's how we can get back the alphabets, by adding 97 into the values in the hash table. Right? So this is how you can count. And if any number is more than 1 time, then there are duplicates. Alright? So let us write on a piece of code here to perform the same procedure and display only those alphabets which are appearing more than 1 time. Like I and N is appearing more than 1 time, let us display only those. So what all we have done, I will write on the same thing here. So first of all, I need a hash table H of size 26. And I need I also. Now using a for loop, I will scan through a string for I assign a of I is not equal to null character and I plus plus. Now for every alphabet, whatever its alphabet is, subtract 97 and store in the hash table. So in a hash table, at what index? Whatever a of I is, from that subtract 97 and add 1. So for that I will assign plus assign 1, or even I can say plus plus. So I'm incrementing it. So in a hash table at a given index, like for example, a of I is f. F is 102. This is 102. 102 minus 97. How much this is? 5. So this is 5. So this becomes what? H of 5. H of 5 is incremented by 1. So h of I plus 1. It becomes like this. So for every alphabet, it will be calculated in the same way. So the indices are obtained. So this is how the entire hash table array will be filled. The next, I should scan through this hash array and find out if any value is more than 1. If it is more than 1, then alphabet is repeating. So I'll continue writing. So this is the end of a string. We have scanned through a string. Now we have to scan through a hash table. Hash table starts from 0 and hash table end at 25. So less than 26 I can write here. Then I plus plus. Then what I have to do is, if at any place of h of I, if it is greater than 1, means there are more than one occurrences of an alphabet. So which alphabet? So I will print it, printf, percentile C. I have to print the alphabet. So what I should do, suppose here it is more than 1, 8. So add 97. So it is 8 plus 97, it is 105, and 105 is I. So this I is repeating more than one time. So I have to add 97 for this index. So whatever the index I is, right now I is pointing here, right? So it is pointing here. So I plus 97, and also how many times it is printing, appearing, I have to print that one also. So printf percentile D, I will print the number of times. So that is h of I gives you the number of times. This will be done only if the value at that hash table is greater than 1. So that's all. This is the procedure. So you can know the alphabets which are appearing more than one time. Duplicates you can find out. Now if we do the analysis, how much time it is taking, we are scanning through this string. So string is linear always. So let us say n. And again we are scanning through this hash table. So this is also linear. So this is also n. As I said that we don't check the sizes. We see that whether the behavior is linear or not. Like the number of alphabets here are a total 7. And hash table size is 26. We don't say that these are different, right? We say that this is linear. So n. This is also linear, n. So this is 2n, 2 times linear. So 2 times linear is also linear. So the time is big O of n. Now this is a student exercise. So you have to write on this program and check it by yourself. There is no demonstration on this one. So you do it by yourself. And one more thing, I have shown only for lowercase alphabets. Now if there are uppercase also, right, or upper and lower cases are mixed, then you have to increase the size of hash table. You may have to take up to size 122. So you try for that one also. So that's all in this video. Now there is one more method, that is using bits, that I will explain you in next video. Yeah, in this video we will see how to find duplicates in a string if any alphabets are repeating. So we have already seen the same thing in previous video. We have learned 2 methods. Now the third method, that is using bits. So in this video we will learn how we can perform the same thing using bits. This method is not just for a string, but it is useful for integer numbers also, but it is more favorable for a string. So let us see this method. So for learning this method, we should have some concepts with us. So let us revise those concepts. Then we will find the duplicate elements in a string. See, the concepts that we should know is bitwise operations. What bitwise operations we should know? Left shift and bits ORing, which is also called as merging, and bits ANDing, which is also called as masking. So we should know these things. Then we will see how to find duplicates. So let me explain you about all these things one by one. So here is a byte. See, for understanding bitwise operation, we should know how the data is stored in the memory in the form of bits. So for understanding that, I have taken just 1 byte. So it is sufficient to understand by using just 1 byte. Suppose I have a variable which is taking only 1 byte. Let us say character type variable. So I am calling that variable as h and it is taking 1 byte. So 1 byte is 8 bits. 8 bits makes a byte. So I have taken 8 bits and this is called as least significant bit and this is most significant bit. Means this is 0. Usually in an array we start indexing from 0, 1, 2, 3 onwards. That is we go from left to right. But this is indexed from 0 to 7 on this side. We started from right hand side. So this is least significant bit and this is most significant bit. Now how any number is stored in the form of binary, zeros and ones. So for this you should be knowing binary number system. I am not going to explain you binary number system. Now we will understand bitwise operations. So for that, let us assume this h is initially 0. Say h is 0. If I declare a variable of type character and say h assign 0, then 0 will be stored. So how 0 is stored? All these will be zeros. Yes, all these will be zeros. Then if I store 1, then this will be 1. So how it looks like in the memory? 0, 0, 0, 0, 1. If I read it from left hand side, because we usually read from left hand side. So this is 0, 0, 0, all zeros, then last 1. Then if I store 2 here, then binary form of 2 is 1, 0. So this is 0, 0, 0, 0, 1, 0. Yes. Then if I store 4, then the binary form of 4 is 1, 0, 0. So this will be 1, 0, 0. If it is 5, then the binary form is 1, 0, 1. So it will be 1, 0, 1. Let us make it back as 4 only. Now next I will skip 6 and 7. Let us take 8. If it is 8, then binary form of 8 is 1, 0, 0, 3 zeros. So this looks like this. So this means that this binary bits represent 1 and this represents 2, then this represents 4 and this is 8, double. It is getting doubled every time, right? 16, 32, this is 64 and this is 128. So yes, this is how the binary value of each digit, right? So if suppose we want to store 10, then 8 and 2, these two will be 1, 1, right? This becomes 10. Just we want 8, then this is 1 and all are zeros. Right? Suppose we want to store 20. This 16 will be 1. So nearest number is 16, right? 32 will be greater than 20. So nearest number is 16. Then what is remaining? 4. So this one. So these two will be 1. So it will become 20 in binary form, binary number system. Right? If only this bit is on means 16. So we have seen how binary form of a number is stored in the memory, right? Now next we will see what does it mean by shift operation. So I'll remove this and explain you. See, right now h is having 0, 0, 0, 1. So right now h is 1. Okay. Now let us see what does it mean by shift. H left shift 1 and the result in h only, right? So whatever the value of h is, see here is 1 bit, or whatever the bits are 1, whatever it may be, all bits will shift by 1 place on the left hand side. If you mention 1, all bits. So we have all bits as 0, only that 1 is there. So it moved by 1 place. So this 1 comes here. Then this place will be vacant. No, this will be filled with 0. If the bits are shifting on this side, then you get some blank bits here. So that will be set as zeros, right? Now what is this number? It has become 2. Yes. Then let us put it back, this as 1 only and this as 0. Now if I left shift by 2 places, h left shift by 2 places. So this will be shifted by 2 places, 1, 2. So that 1 comes here. Then this is 0. So now how much it is? 4. So as I said, left shift and the result stored in h means this h will modify and it will become 4. So only this operation will not modify h, right? We have to store it. Now it means by shifting the number on the left hand side, we are able to increase it multiples of 2 and also the digit is shifting, right? Suppose here I say H left shift by 5. Right now it is 1 here, right? By 5 places. So 1, 2, 3, 4, 5. So it will come here. So what is the number now? See, these are all zeros. Only this is 1. So this is 32. Right? So we can shift the digits. So we can shift all the digits, but we are interested in only one digit, that is 1. So we are looking it through an example 1. So I have explained you shifting. Now I will explain you and ORing. So first let us see ANDing, then I'll explain you ORing. So for explaining AND, I have taken an example. I have taken two variables here, two variables, A is a 10 and B is a 6. So I have taken just four digits of those number, because these rest of the digits on this side are zeros only. If I write all 8 bits also, they are all zeros. So I am showing only the useful bits, right? So these are last 4 bit and these are last 4 bits. So it is just like 1010 for A, and for B it is 110. So I have used this one also because that makes 4 bits from each side. Now what is AND? If I say A and B, then bits are ANDed. 0 and 0 means false and false, is false only. 1 and 1 means true and true, yes, true only. So 0 and 1 means false and true, is false. Then 1 and 0 means true and false, is false. See, you may be knowing this. If you have A, B and you are performing AND, so this is 1, 1 is 1 and 1, 0 is 0 and 0, 1 is also 0. 0 and 0 is also 0. So when you perform AND operation, then this is the result. So but we are performing not logical AND, we are performing bitwise AND, single ampersand. So the ANDing will be done upon the bits of numbers, bits in the memory. So what is the result we got? This is binary form of 2. So it means 10 and 6 is 2. 10 and 6 is 2. So this is AND operation. Next, I'll show you OR operation. Then we'll move ahead. Let us see OR operation. See, same number. I'll remove this. Now, instead of ANDing, we are performing OR operations on a bit. Then OR means what? 0 or 0, 0 only. 1 or 1, 1. 0 or 1 is also 1. 1 or 0 is also 1. Then, how much this is? This is 14 in the decimal number. Binary form it is 1110 and it is 14 in decimal number system. See, this is ORing. ORing means what? 1 or 1 is 1, 1 or 0 is also 1 and 0 or 1 is also 1, 0 or 0 is 0. So if any one of the bit is 1, then it is 1. So that's what we have performed here. And 10 or 6 is 14. So this is interesting, bitwise operations. Now let us understand what does it mean by merging and masking. This I have explained you and OR operations. Now merging and masking I will explain you. Now let us understand masking. See, for explaining masking, I have a variable h of 1 byte size and the value in that one is 16. So 1 is present here, so it is 16. All are zeros. Then I have another variable a in which everything is zeros, right? Now I want to know whether inside h, this bit is on or not. 1, 2, 3. This bit, is it on or not? I just want to know that. So that means third bit, thirdly significant bit. So from here, 3 places. So I will find out whether this is on or not. Right now it is off, right? So how to? Now for explaining masking, I have taken 2 variables, h. H is having all zeros except this one. So the value inside that is 16. So this is 1 byte long, right? So h is having value 16. Then there is one more variable a and it is having 0. Now what does it mean by masking? See, I want to know whether at this place, that is bit 2, 0, 1, 2, right? At this bit, is it 1 or 0? I want to find out that, right? How to find out? Inside h, I want to know whether this bit is on or not. That is 0, 1, 2, second bit, or if I count 1, 2, 3, third bit. So let us call it as 2. I want to know whether that bit 2 is on or not. So how to know that? So I will take the help of A. So inside A, I will write down 1. So this is A assign 1. Then I want to check this one, right? So 1, 2, 3, 1, 2, 3, that is 2, least significant bit 2. So move this one 2 times. So left shift A by 2 places. So this one will move here, then move here. So it will move here and it will become 0. Now we have A with 1 moved by 2 places. So what is the value in A now? It is 4. Value in A is 4. So remember, I have shown you these, right? So this is 4, this is 16. It is 16 here and it is 4 here. Now, how to know whether this bit is on or not in this one? Perform ANDing. If you perform ANDing, then 0, 0 is 0, this is also 0, this is also 0, this is also 0, this is also 0. All are zeros only. So if you got 0 means bit is off. If you got non-zero value means bit is on. So by performing AND between A and H, I can know whether that bit is on or not. So knowing a particular bit inside a memory, whether it's on and off, is called as masking. Now let us do it for this bit. See, already this bit is on. Let us check for this one. So first of all, set A as 1. Okay, A as 1. So this is at which place? 4th place. So move this by 4 places. So it will move 1 by 4 places. Left shift. 1, 2, 3, 4. So it will move here. 1 will move here. Actually all zeros also will move here, right? It's not crossing over this one. See, it is just like this. When we are shifting means this 0 comes here, this 0 comes here, this 0 comes here, this 0 comes here, and so on. And 1 will also move. Like that it will happen 4 times. Alright. So this 0 is here now. And these are all new zeros that came there. So it is left shifted and it is here. Now if I perform A and H, I'll get true. Yes, this is true. So it means that bit is on. That's perfect. Now next thing, I'll show what does it mean by merging. Right. See, already this bit is on in this one, right? And I want to set this bit as on. Inside H, I want to set this bit as on. So for setting that bit as on, I will take help of A as 1. Yes, left shift A by 2 places. So A will move here, A will come here, this will become, that 1 will come here, and that remains 0. Then perform OR and store the result in H only. So 0 or 0, 0, 0 or 0, 0, 0 or 1 is 1. Right, and this is 0, this 1 or 0 is 1, so this is 0. So the result of this one will be 0, 0, 0, 1, 0, 1, 0, 0, right? So this will be the result, and that is stored in H, so this becomes 1. So already some bits were on and we have set other bit as on. That is called as merging. Setting the bit on in memory is called as merging. Checking whether it is on and off is called as masking. So these two operations, we have seen bitwise operations, left shift, masking and merging. All these things we will use now for finding duplicates in a string, right? So finding duplicate, we will see it in the next video, that is continuation video. So otherwise it will be a very big video. So let us break it. So watch the next video for finding duplicates using bitwise operations. This is the continuation of previous video. If you have not seen previous video, go back to previous video. There I have explained how we can use bitwise operations to manipulate the bits of a byte in the memory. We have seen masking and merging. Now we will use that masking and merging to find out are there any duplicates in a string. So already we have an example string where I is repeating and N is repeating. So just we can find out are there any duplicates or not, right? We cannot count how many times that element or a character is repeating by using bits. So just we will find out whether the bits are already there or not there. So let us see what we need for this procedure. See, similar to hashing, we need some space. So in hashing, we have taken an array of 26 size. So now we need 26 bits, but we cannot get 26 bits. We get in terms of bytes. So 8 bits makes a byte. So we can get 32 bit, that is larger than this one, right? Otherwise we get 16 bit, that is 2 byte, that will be less than this one. So together 32 bits we can take. So what is 32 bit? So that is 4 bytes. So 4 byte means what? Either it can be an integer or it can be a long integer. So long integer takes 4 bytes. See, we have been assuming that integer takes 2 bytes, right? I was assuming this one. So if integer take 2 bytes, long take 4 byte. But in some compilers of C, C++, integer itself takes 4 bytes. So just an integer is sufficient. You don't have to take long for it. So 32 bits or 4 bytes you can get just using an integer. So I am assuming, as per my assumptions, I am taking long int, right? So that is of 4 bytes. Now what to do with that 4 bytes? So first of all, I will draw 4 bytes, then we will discuss. Here I have 4 bytes, right? So this is the least significant byte and this is least significant bit, 0 to 7. Then next byte is 8 to 15 and so on. So this is just like a hash table. In the hash table, we have taken a hash table of size 26 in the previous video, right? So here we are having total 32, 0 to 31. So actually we need up to 0 to 25, right? Up to here it is useful. Few bits are extra, that is not an issue. Then all these bits assume that they are set to 0. Yes, they are set to 0. So for this, I will take one variable there. I will take one variable long int h and this is initialized with a 0. Yes, so all will be zeros. Now, this I will use it for finding duplicate. How? I will scan through a string. For every alphabet, I will set the bit on here. But the ASCII code of this is 102, right? So actually from 102, we will subtract 97 and we get 5. So we'll set this fifth bit on, right? You remember in the hashing, we have done the same thing. At the fifth index, we were incrementing it. But now we will set this fifth bit on. And for this I, it is 105. So 105 minus 97 gives 8. So we'll set this 8th bit on, right? So next time when we come on this I, then again it is 8. So we will go and check 8th bit. It's already on. So I is duplicated. So before setting it on, we will check whether it's already on or not, right? How do you check whether that bit is already on or not? By performing masking, ANDing. Yes, we know that that is already on. If it is already on, then we say it's duplicate. Now A of I is F, letter is F. It is 102, right? So as it is 102, I will subtract 97. So A of I minus 97. So for every alphabet I will do it. So for this I will get 5, for this I will get 8. So now what to do with this 5? I have to check whether this fifth bit is on or off, whether this fifth bit is on or off, right? 0, 1, 2, 3, 4, 5. If you count it is 6th bit, but index is 5. So that bit is on or not. So how to know that? By performing masking, I can know that. So I should have one more variable where this bit is set on and I should perform masking. So for that, I will take one more variable that is set to 0. And here, before this, I will set x as 1, right? I will set that x as 1. Then that 1, I have to make this x shifted for 5 places so that it comes here. So this difference, whatever the difference is, I should shift this x. So x left shift for these many times and assign it to x. So I'll write x here, x assign 1. Now this is little tricky statement. Check this. X is 1, right? See, this is another one. I am not drawing boxes here, right? Already I have boxes for variable h. So similarly, assume that these are the boxes for variable x. 0, 1, 2, 3, 4, 5, 6, 7, right? These are the boxes. So I'm showing only for the one variable, right? Otherwise I have to draw all of them. This is variable x, right? Which is 0. Now first set it as 1. Then left shift this x by these many times. So how much it is? Right now f is 102, so 102 minus 97 is 5. So it will shift this value 1 by 5 places. 1, 2, 3, 4, 5. So 1 comes here and all these are zeros. All these are zeros, right? All are zeros. So I got 1 here. Now check inside H, is that bit is on or not. If it is already on means it's a duplicate letter, means already it's there. If it is off means set it on. So I will check here. How to check whether this is on or not? By masking. So X and H. If X and H, the result by ANDing is greater than 0, means we got some non-zero value, right? If that is off means we get 0. If that is on means we get non-zero value. If it is so, then print that so and so letter is duplicate. So printf percentile C is duplicate. Percentile C is duplicate. So who is duplicate here? That is A of I. For F it is not duplicate. For I and N you will get duplicate. So A of I, whatever I is. Right? It's already there. If it is not there, means if it is not 1, then set it as 1. We got that digit. We got that alphabet. So set it as 1. How to set it? By performing merging. So X or H. Store the result in H only. So this will be set as 1. So that's all. This is the close of loop. So wherever there is a duplicate, it will display that alphabet. If any duplicate alphabet is there, it will display it. We have used shifting for preparing a number so that we can perform masking and merging, right? So for this bit, for F, bit comes here, and for I, 8th bit will be on, right? This will be on. So we check for this one, is it present or not? So in this way, the bits for 5, this will be set on, and for 8 it will be set on, right? And for this one, 103, this is 103. This 6th bit is also set on. So this is 102, and this is 103, and this is 100. So this is also 1 for 100. Then 105 is already over. Then 110, 5, 6, 7, 8, 9, 10. So this is also on. So rest of them all will be zeros, and these bits will be set on. And when again it finds that I is already there, so I is 105, so 105 it is already there, so this is duplicated. Then for N, 110, first time this will be set on, second time it will check here, this is already there, so this is duplicate, right? So for checking this one, we need 1 here in X. So how we are getting that 1? Initially we are setting this as 1 by this and shifting it that many times, right? Shifting it that many times. How much times? See, 110 minus 97, so this is 13. So it should be moved by 13 times from here. So I will show here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So it will come here. Then we'll perform masking to know whether it's already on. If not, we will set it by merging. So this is how we can use bitwise operation to know the duplicates inside a string, but we cannot count, just we can know whether there is a duplicate or not. And we can know what is that letter that is duplicated. So that's all. This is a simple program, so you can write down and check it, right? And if you face any difficulty, you can pose a question, right? If you want me to give you the program, I will give the program. That's all. Now the topic is checking whether two strings are anagram or not. So first of all, we'll see what does it mean by anagram. Then we will see what are the possible procedures one by one. See, anagram are two set of strings which are formed using same set of alphabets. So for example, here I have a word that is a decimal, and same alphabets that are D, E, C, I, M, A, L, same are used here to form another string that is medical. So another word. And it is having same set of alphabet. D is there, E is there, C and I, everything is there. So these are anagrams. So the problem is to check whether two strings are anagram or not. So the first and the foremost thing, check whether two strings are of equal size. If they are different sizes, they cannot be anagram, right? The first condition. So we assume that they are of equal sizes. Yes, we have taken equal sizes. Otherwise, we have to check. So this is based on assumption they are equal in sizes. Now, how to check whether the strings are having same set of letters? One simple approach is take alphabet from a string and search here. D is found. E, yes it is found. C, yes it is found. I, yes it is found. M, yes it is found here. A, yes it is found here. L, yes. For every letter you can check through this entire string, right? If suppose any one of the letter, this is not L, if it is K, then when you search for K, it is not found. So you can see that they are not anagram. This is simple. I'll put it back, right? So how much time this procedure take? Every letter search here. Searching in this one linear. So linear is n. That is linear search we have to perform. So time for searching is n. Then for this letter also search. This letter how many times? N times. So this is n into n and this will be big O of n square. So big O of n square time. So the procedure I have shown you, this is the simplest procedure and this takes order of n square time. So this procedure is time consuming if you do it like this. Then one more thing we have to take care in this one. What is that? See, there are no duplicate alphabets in this one, right? I have not taken any duplicate alphabet. If there are any duplicates, then you have to deal with that complexity. So we have already learned about counting number of duplicates in an array and we have used the logic, that same logic we can apply here, right? So we have already seen that logic, you have to implement it. Now let us look at the second method, and the second method also we are familiar with, that is using hash table. Yes, this is hash table. I have taken an array of size 26. So already we know why we are taking size 26, and we already know in the previous video we have learned that how we can make use of this hash table. And one thing, all these are lower cases. So if you say no, I have upper cases also and the digits also, special characters also, then you should have a array of size 128. So I have taken only 26. Now how we can make use of this one? Let us see, using hash table, how we can find are these two strings anagram or not. Let us see the procedure. First of all, I will write down the ASCII codes of these lowercase alphabets, right? So this A is 97, this is the ASCII code, right? And the C is 99, D is 100, E is 101, then I is 105, L is 108, M is 109. So these are the ASCII codes of lowercase alphabets that are used in this string, right? I already know the ASCII codes, so you can refer, you can check in Google and you can find out what are the ASCII codes of the alphabets. Now let us see what we have to do next. Scan through this string. So we know how to scan through the string using a for loop. We can go to each and every alphabet. Then for every alphabet, like this is 100. So 100 minus, this is 100 minus 97. So this gives 3. So at 3, increment. So assume that all these are filled with 0. So increment. So it becomes 1. I have not written zeros. That looks congested. So I have just assumed that these are all 0. So this became 1. Now next is 101. So this gives how much? 4. So actually this was 3. So 4. Go to index 4 and increment it. Now next is, this is 99. So this will be 2. Go to index 2 and mark it. Then this is 97. If you subtract from this one, then this will be 8. Go to index 8 and increment it. Then go to index, this is 109. 109 minus 97. This will be 12. Go to index 12 and mark it. So this is 12. And this is A. So 97 minus 97 gives a 0. So increment this one. Then this 108. So 108 minus 97 is 11. Go to index 11 and increment it. So see, all these alphabets are unique. There are no duplicates. So we got just 111. Suppose if any character is repeating, then it will increment and it will become 2. So this procedure we have already seen it earlier for finding duplicates from a string. So this is the same thing. Now what is the next step? Next step, scan through this string, right? Scan through this string, and for each character M, so it will be index 12. So this is actually ASCII code is 109 minus 97 gives 12. Go to index 12 and decrement it. So it became 0. See, it should not become -1. So if already 0 is there, means it is becoming -1, means this alphabet is actually not there, right? So you can stop then and there after subtracting if it becomes -1. All right. The next alphabet E, its ASCII code is 101 and index will be 4. Go there and decrement. So 1 minus 1, 0. So yes, it is not becoming -1. D, its index will be what? It will be 3. We have already calculated here. So go to 3. So index 3, decrement this. So this is not -1, it is 0, right? Then I, so we are here now. I's ASCII code is 105, minus 97 is 8. Go to index 8 and decrement it. Then C's ASCII code is 99 and its index is 2. Go to index 2 and decrement it. Then A, decrement it. L, decrement it. Finish. Now, we never got a -1 value. It means all the characters are as it is available here. So these two strings are anagram. If we got a -1, we can stop then and there. So this is the procedure. By using one string, you can maintain a count in a hash table, and second string you can go on decrementing it. If any number is reducing below 0, that is becoming -1, means it is not found, you can stop. And otherwise you can scan through this entire array once more and see that, confirm that all are zeros, right? If anything is not 0, you can stop and say these are not anagram. So let us do some analysis. How much time it is taking? We are scanning through a first string, so how much time it is? It is linear, so it is n, and this is also linear, so it is n. And then this table we are accessing every time. So how much time? We are not accessing entire table, we are accessing a particular location, right? So accessing this table takes no time because we are not scanning through this entire table, right? So we don't have to include its time. If at all, if you include also, then this will be n plus n plus n. This is 3n and it is order of n. Basically, we are not accessing this, so it is only 2n. So 2n is also big O of n or order of n. So the time is order of n, right? So let us write down the program code for this one. See, we need a hash table. So for that, I will take an array of h size 26 and initialize with a 0. I already have A and B as two strings, that is decimal and medical. Now I should scan through this first string. So using for loop, scan through a first string. For I assign 0 as long as A of I is not equal to null character and I plus plus. And every time what I have to do, whatever the letter is, its ASCII code minus 97, at that index you increment it. So whatever the element is, character is, minus 97, use this as an index of hash table and there increment it by 1. This is first string. Then this is over. Now second string, again I have to scan through a second string. For I assign 0, I, that is B of I is not equal to /0 I plus plus. Then what I have to do every time, whatever the alphabet is, I should decrement at the same place. So the same thing, h of A of I minus 97, at that place minus assign 1. So 1 will be decremented. But after decrementing, check if it has become -1. If h of A of I minus 97 is less than 0, if it is less than 0, just print not anagram, not anagram. All right. Then also break, come out of this loop. Got it? Continuation, there is no space here. So if this is less than 0, then say not an anagram and come out of the loop. And if we come out of the loop, we may be coming out somewhere around any of these character. We will not be reaching /0. So outside this loop, check if we have reached /0, b of I is equal to null character, then it means everything was perfectly checked. So printf its anagram, printf this one. So this is the procedure. This is a simple code, very simple code, 2 for loops and some conditions. So you can try it by yourself. You can write on the program by yourself. So this is a student exercise. Do it by yourself. Right? So that's all with this topic. But one more thing I will show you in this one. What if there are any duplicate alphabets? See, the alphabets are not repeating. D is not repeating, E is not repeating. If there are duplicates, then what? So I'll remove few things and show you this one quickly. Yeah, here I have duplicate letters in a string. Like this is verbose, E, E, and observe E, E is repeating. So how to handle this one? So we don't have to take a special care for this one. The same method will manage this. How? Let us see. This is when we come on this alphabet E, its ASCII code is 101. So 101 minus 97 is 4. So at index 4 it will become 1. Increment, right? The next time when we get another E, so again at the same index it will become 2 as we are incrementing it. Right? So I am just taking duplicates. Now while we are checking this is string, it's an anagram of that one or not. So for O, B, S, everything we check. Then when it comes on E, we go to the same index and decrement it and it will become 1. Then we come to this E, again we'll go to the same index and it will become 0. So it will not be -1. So even using hashing, using hash table, we are able to get the duplicates also. Now the last point. You can check whether two strings are anagram or not. If they are not having duplicates, you can use bit set also. The set of bits already we have seen in the previous videos. So you can refer the video. We can use those set of bits also. That is, using bits also we can find out if there are no duplicate letters in a string. Otherwise, at a bit we cannot store 2 or more than 1 we cannot store. So that's the reason hash table is useful for duplicate letters also, but bits are sufficient if there are no duplicates. So that's all in this video. You have to write down these programs and practice them. The topic is permutations of a given string. So first of all, we'll understand what does it mean by permutation. Then we will see the method how to find permutations. There are more than one method. So in this video, I'll show you one method. Then in the coming video, you can find the second method for finding permutations. So first of all, let us understand what does it mean by permutations. See, there is a string here, alphabets A, B, C are there. Then we want all permutations, means all arrangements of A, B, C. So like if A, B, C is given, then one of the permutation, one of the arrangement is A, B, C, then A, C, B, this is the first one, this is the second one, third one is B, A, C, fourth one B, C, A, and fifth one is starting with C, then first A, then B, then sixth one is starting with C, first B, then A. So there are total 6 possible arrangement of those alphabets of a string. So how many, if there are 3 characters in a string, then how many permutations are possible? 3 factorial are possible. It means for n, how many possible? N factorial are possible. So we want all those arrangements. Now how to get those arrangement? So for that we will devise some procedure, or we will devise some logic for generating all those permutations. So first let us do some board work to get the idea how we can get those permutations. So here I'll do the board work. See, let us say this is the starting point, and next the first alphabet, I'll say first alphabet A, the next alphabet B, the next alphabet C. So here I got the result A, B, C, if you come along this one, right? So this is, I am forming a tree, right? So from here, go back So after that B, there was only one alphabet. Okay, go back to A. When I am on A, I can go on B as well as I can go on C. So B already I have taken. So let us go on C. Then from A, I have gone on C. So what is remaining? B is remaining. So then what is the result? B, C, A. So this is B, C, A. So I got two different arrangements. So I can show these arrangements in the form of a tree. Yes, then after C there was only one letter B. Then after A, B and C both are over. So let us go to next letter B. If I start with B, next letter should be either A or C. So first I will take A, then I will take C. So this is another permutation, that is BAC. So that is BAC. Then go back. After A, only C was left. After B, C is possible. Then next is A. So BCA. This is BCA, another permutation. So for B, A and C both we have tried. So let us go back to the main starting point and take the next letter C. So now I am starting with C. So what are remaining? A and B. So first I'll go to A, then B, then it is CAB. Or else I'll go back and from here I will take first B, then A, then it is CBA. That's all. 1, 2, 3, 4, 5, 6. These are 6 permutations. Yeah, here I have to write ACB. Yes, this is ACB. So I have total 6 permutations that are what we wanted, right? 6 permutations. So this is like forming like a tree. So this tree is representing all various possible solutions. So this tree we can call it as state space tree. State space tree, where the leaves are showing us the results. Then one more thing we will observe about the tree. Start from here, go to A, go to B, go to C, go back. So again from there go on to C. So this going back and again taking another route, this we can call it as backtracking. So this is representing backtracking. So we have learned one more term. So 2 terms, this is state space tree and this is backtracking. The approach is backtracking. And one more thing we'll learn here. See, from this A, B, C, what all possible permutations, all are shown here. Everything is explored here. So this is called as brute force. Brute force. See, these are different terms. I'll explain you. Brute force means finding out all possible permutations. That's the meaning of brute force. How you do, it's up to you. Here we are using backtracking. So backtracking, if you observe in this tree, we have gone on to A, then B, then C, then we got a result, then we went back, then we took another route. We have went back and taken another possible route. That's what is backtracking. These are the 2 things we learn. Now the last and the very important thing is, see, whenever you have a procedure, in the procedure if you have to go back and take another route, then those procedures can be implemented using recursion. Yes, recursion. See, we have to use recursion to achieve backtracking, and with the help of backtracking we are performing brute force. So this looks like all same thing, but these are different thing. Recursion is a recursive procedure. It can do anything. There are various forms of recursive procedure. But a recursive procedure which is trying to explore everything is a backtracking procedure. Right? And if a procedure is backtracking and finding out everything, then that procedure is called as brute force. So this can be done using loops also if you want, but you have to use a stack for using loop. So this is mostly implemented using recursion. So backtracking is implemented using recursion, and backtracking is used for achieving brute force or taking up brute force approach. Right? So these are the terms that we have learned from this example. Right? So the example is to find all permutations. Now we will work on the example. We will study this state space tree, then we will try to devise a recursive function which will generate all these things. So let us work on recursive function. For writing a recursive function, let us observe this state space tree. See, it is starting from here. And where are the answers? We are getting the answers at the leaf nodes. Yes, this A, B, C, A, C, B, so on. We are getting the answers at the leaf. As it is recursive, let us say it is starting from here. So this is the first call. This is the first call. This is within the first call. Within the first call, we are taking first letter. Then it is calling itself. In second call, again it is calling. So in second call, we'll take a letter B. Then the next call will take a letter C. Then it will go back to the previous call. Go back to the previous call. Then in this call, again it will call itself. So it means being on A, it is calling on B also, C also. Both it is calling. So when we have taken C, then we will take the missing one. Remember this, missing one. So we should know which is missing, which is not yet taken. So after A, we are directly on C. So B is missing. We should know which is taken, which is missing. It will take B. And at the leaf, it will print A, C, B. These are the three letters there with us. Right? So if you observe in the first call, it is going on first letter also, second letter also, third letter also. It's going on all. Then if I drill down to the next level, in the next level, leaving the first one which is already selected, it is selecting both B and C. Yes. So it means it is traversing through a string in each call and picking those which are not yet selected. And at the leaf, it is preparing a single string and displaying a string. So we need a few data structures here. Already we have a string, but we need to prepare the result, this result. So let us take a result. So we'll take an array as a result. This should be of same size, right? 0, 1, 2, 3. So in this we will be storing these alphabets A, B, C. Then we should also know which one is included, which is not included. So for that we will maintain a flag array. So I will call it as A, right? And this is 0, 1, 2, 3. And initially all these values are 0, means nothing is selected. Now I will trace this tree and prepare few strings and give you the idea. Then based on that, it will be a very small function. So I will write on the function also here. Let us first observe how it is working. Now let us trace this one. So for this, we need to start with the K, that K as 0. That is in this call, K is 0, right? So K is 0. For that we will take A, B and C. So we should know which one is taken, which one is not taken. And we have to scan through this string. For that we will take I here. So in the first call, K is 0. And here I is 0 right now. Now in the first call we will check whether this A of I is a 0 or not. Yes, it is 0. So we'll make this as 1, right? And write A here and call itself again. Call itself again recursively. So when it is calling again, it will call for the next level. So K should be on next location. So at this level, K is at 1. Then what about I? Now at this level also, I should scan through the entire string. So again start I from 0 only. Start I from 0. I 0, is that alphabet available? No, we have already taken. Then I plus plus. Is this alphabet available? Yes, it is available. So mark this as 1. At this place, B is there in the string. So write B, right? So I is now at 1. Then call itself again for the next level. Whenever you got a letter, call next level, that is K plus 1. So it has to call for the next level, that is for this alphabet, right? So now K is 2. At this level, K is 2. Now here also, it should scan through the entire string and take those alphabets which are missing. So it should take an alphabet that is missing so far. So again, I starts from 0. Check, is it available? No. Next one, I plus plus. Is it available? No. Is it available? Yes. So I is here, mark it as 1. And at this place 2, the letter is C. So take C, right? So right now I is at 2 there. I is at 2. It has got the character. So again it should call itself. So this time again K starts from next letter, that is K plus 1. So it will call itself on the next alphabet. Now again I should scan the string. But no, check here. K has reached index 3, and in the string main string it is /0, means K has reached at the end of a string. No doubt K is representing this string, but at the same place if you see matching place, that is null character, means we should not go further or we should not process anything here. We have reached the end and we got the result. So at this place K, put /0 and print this one. So in the next call printing is done. In the next call, when K is equal to 3, printing is done and we will not scan through this string. So this is one step I have shown you. We have reached the result for the first time. Now if you have understood this, then you can understand all other. Though I have to continue, I'll show you few more, than how it is working. You can understand it clearly. Now till here you should be clear what all has happened. This was the first call. First time K was at 0. This is for the result array, right? Then we got A, then we got B, then we got C, then we got reached the end. So we have printed A, B, C. Right? Now, once you have printed A, B, C, don't go further. Go back. Go back to the previous call. So go back to the previous call means where was K, where was I? Let us know. K was at 2 and I was also at 2. So K was at 2, I was also at 2. Then what to do here? What we were doing, scanning the string, continue the scanning the string, continue scanning. So before going to the next, make this as 0 and proceed. If you reach here, this is null. So finish scanning in this level, right? So finish scanning means again go back to the previous call. So in the previous call, where K was and where I was, K was at 1, I was at also 1. So what you were doing here, scanning through the string. So continue scanning. But before that, make this as 0 and proceed. So when you go back, make that as 0, right? Make it as 0. Then continue scanning. Okay, continue scanning means next I++. Is it available? Yes, that is 0. That is 0. Yes, it has to be taken. So at this place it comes to this one, right? See, K is 1 and I is 1. Here K is 1 but I is 2. Yes, K is 1 and I is 2, and this is available. So whenever a letter is available, mark it as 1, take that letter, call itself again for the next letter, call itself again. So K is now 2. Then again start scanning the string. So in every call we are scanning through the whole string. I starts from here. Yes. Is it available? No, not available. Next, I++. Is it available? Yes, that is not taken. So make it as 1 and write B wherever this K is pointing, because this is B. So write B here. Yes, we got that letter B. So where I is pointing right now? I is pointing at 1. Yes. Then call again itself again. So when we have call again itself, K has reached null. So K has reached null means in this call print. Now this is printed. Now after printing, go back to the previous call. Where K was in the previous call? Previous call K was at 2. Then where I was at 1. Then what to do? Continue scanning. So but before that, make this as 0 and continue. Is it available? No, it's not available. Next, is it available? Oh, you have reached null. So we have finished with this level. Go back to the previous. Once you have finished, go back to previous. So where K was at 1, where I was at 2, K was at 1 and I was at 2. What to do? Whenever you are going back, you have to mark that as 0. Yes, mark this as 0. Then continue scanning. Next, that is null. So we have reached null. Then go back. Go back means which call now? This one, right? This one. See, we have finished this and finished this and finished this. So where K was at 0, where I was at 0. So K was at 0, I was also at 0. Then what to do? Make it as 0 and continue next. So make this as 0 and continue next. So I is here. Now I will show you one step that will be sufficient for you to understand everything. Now in this step we are scanning through next. So we are here now. So where is K? K is at 0. Where I is now? I is at 1. And is it available? Yes, that's why I'm writing it. So make it as 1 and copy this at K. So this becomes B. then call itself again. So k becomes 1. K becomes 1. I starts from again. So is it available? Yes. Make it as 1. Copy A here. Make it as 1. So I is at 0 right now. And copy A here. Then call itself again. K will be on next. And again start I from 0. Is it available? No. Is it available? No. Is it available? Yes. I is here. So make it as 1. Copy that letter C. So K is at 2 and I is at 2. So yes, print BAC. So here you can see that it is BAC. Yes, we got that permutation. Now as we have reached null, this is null, so we have printed. Now do what? Go back. Go back where K was and I was. K and I both were at 2, so this is 2. Then what to do? Whenever you are going back, make it as 0 and continue. So there is nothing. So again go back. K is at 1 and I is at 0. So K is at 1 and I is at 0. What to do? Make it as 0 and continue. So continue. This is already taken. This is not taken. So yes, now we get C. So here it will be. So this is the second step in this call. So K is at 1 only, but so this will be selected and C will be written here. Then obviously A will come next. So that's how it carries on. Now let us write a function for performing this permutation. So here I will write down that function. So let us start writing the function. Void, I will write down the function name as PERM for permutation, and it should take array of characters, that is string it should take, and also it should take K, that is the call number, that is for result. You remember K is 0 here, K is 1, K is 2. So in every call it will be incrementing K and calling itself. Then inside this function we need these two arrays which must be permanently there. In every call they must be present. So I should declare them as static. So if you declare anything as static, then it will be available for all function calls. So I will take an array of size 10A and that is initialized with 0, and also I will take a static in character type array as a result, and this also I will call it as size 10. So these two I have taken. Now next, what I have to do? I have to scan through a string and print it. So for scanning through a string, I need a variable I will take it, and here using a for loop I will scan through. For I assign 0 as long as s of I is not equal to null character I plus plus, scan through the string. Using a for loop you can scan through a string. Then while scanning, what we have to do? Every time check whether this alphabet is available or not. So where I have to check? If A of I, if it is 0, means alphabet is available. If it is available, then what I have to do? Copy an alphabet from S to rest, right? So from I have to copy wherever K is pointing. Like suppose if I am copying this alphabet, right? So C I have to copy here. So from S of I, copy into rest of K. Yes, rest of K. Copy that alphabet, right? After copying that alphabet, inside A of I, mark it as 1. A of I, mark it as 1. The next step is what? Call itself again with the next value of K. Call itself again, that is I am calling the function name as perm, P-E-R-M, right, permutation. So S is string is as it is, but K plus 1. Yes, so this will call itself. So this is for loop, and this is all happening inside if. And when the function call is returning, I should make this A of I as 0 back again. So A of I as 0 back again. This is the step I was doing. And this all happening if A of I is 0. That's all. And this is the end of the for loop. So these are the things that are inside F. And that's all happening in for loop. Then one last thing. When we have reached K at the last, that is, it is null. At this place it is null. So what to do? Print. So that I will write here. If S of K is equals to null character, then printf result. Printf percentile S, print the result. Right? Then in result of K, mark /0 and also print the result. So printf result. I am just writing it as printf result. So this I have to do if Otherwise, if it is not a null, then this whole thing should be done. So all this procedure is in else part, right? When we have not reached null, if it has not reached null, then do all this thing. If it has reached null, then print it. So that I have written it in the beginning. So this is the procedure. And if you want to call this function from main function, so I'll just write on here, if inside a main function, if you have a character string s and it is having letters a, b, c in that, then call this function perm by sending s and starting value of k should be 0. It will print all the permutations. So that's all. See, this is the procedure. I have shown you the detailed working of this one. This you have to do it by yourself by using pen and paper. If you do it by yourself using pen and paper, then you can understand it clearly, right? See what I was discussing, just I was saying ki, ki. So this, once you put it on paper, you can understand clearly. Keep this on a screen, just paused and take a pen and paper and work out by yourself. Then you should be able to devise this one. See, I have devised the whole function by discussing each and everything, right? So you should be able to devise like this. Now this will help you to devise an algorithm for any problem, right? No doubt, initially it may take some extra time for you, much time for you, but slowly as you are in practice, then you can quickly answer these things. So this needs your practice, that is more important. So perform all these things what I have explained here. The complete problem you do it by yourself once. Writing a function, coding it and seeing the output is not important. Framing a logic and procedure is more important. So you concentrate on framing this procedure by yourself. That's all with this procedure. Let us look at the second method for generating permutations of a given string. Second method is not much different. It is same as the first method. Most of the things are same. Just a few differences are there. So let us discuss those differences. Already each and everything in detail I have explained in the previous video. Just quickly I will show you the working and also I will write on the function based on the working. Right? So here is a given string. We want the permutations, right? So you know well about the permutations, so I don't have to explain you about the permutations. Now let us look at the procedure quickly. This procedure will be using swapping of the letters, right? So we don't need extra array. We don't need an array to know which is included or not included. So this is just by using swapping. So let us see the procedure directly. See, the first starting array is given. So we know it is having A, B, C and null. So we need the starting index and ending index, that is the length of a string. So we'll take this as low and this is high, right? So we'll start with this. And this is array S. First call. In the first call, what we will check? We will scan through a string in each call, right? We will scan through it. So for that, I will be at first letter. So when I is at first letter only, so I will not show null now. A, B, C, and the low is here and high is here, I is here. So swap the letter at L and I. So it is swapped with itself. And call again. Call again. Then A, B, C, A, B, C. Now when you are calling again next time, L should be on the next letter, H. See, L is on 1 and H is on 2 only, right? So call this one. Then start scanning. From where? I starts from here only, right? You don't have to take this one. So swap I and L. So B is a swap with itself. Nothing will happen. So you don't see any changes in this first pass. Then call again itself. So here is A and here is B and here is C. L and H. Now I. Now right now L and H, low and high are equal. So don't swap anything. Print this result. So we will be printing here. Printing. Print this one. Right? Now go back to previous call. So previous call, I was here, right? So next call, in the previous call, where A, B, C, low was here, high was here, I was on this place. So now I will move to next. I will move to next. So what we were doing? Swapping I and L. So L is here, I is here, right? So swap, like if I say 0, 1, 2, L is at 1 and I is at 2. Interchange. So this will become C and this will become B. Right? Then call again. Call again. Next call again A, CB. Right now it is ACB. It's not ABC. Same string, right? Same string. And where L will be? At the next place. At the next place. So L and H, both of them are here. Now when they are equal, then do what? Print. Go back to the previous call, right? And swap them back to their original places. All right. Now, can I continue further? No, it is end because it has reached H. It is going beyond H. Go back to the previous call here where I was at this one, right? At this 0, first letter. Then the next call. L is here only, H is here only, and A, B, C. See, the call is same actually. Call is same, but I will be on the next letter here. I is on the next letter. So in each call, we have to scan through the entire string. So I was in the beginning, now I is on 1, right? Then interchange I and L. So this becomes B and this becomes A, right? Then call itself. So when it is calling itself, this is BAC, L will be on the next letter. Start I from here. I is on the same place. No scanning is done. Then call again itself. Then BAC, this is. Then L will be on the next one. So as these are equal, don't do anything, just printf, and go back. So we have done it when I was here. So the next is BAC, then I will be on the next letter where L is here, H is here. So interchange. So this becomes C and this becomes A, right? Then the next call. Here B, C, A, L and H are same. So just print this one and go back. When it is going back, it should copy the things back again in the same places. So it should be A and this should be C. So this is AC and it's going back. So it should copy the things back again, right? A here and B here, and it should continue upon the next call, next place. So this is how it works recursively. I will write on the procedure. Then you look at the tree once again. Void, I will call the function name as PERM, and it should take a string and it should take low as well as high. Next, I need a variable. Then now here I will write on a for loop for scanning I from low, I is less than equal to high, I plus plus. Then inside this swap a string from low to I. See, remember we were swapping the alphabets wherever I and L are pointing. If they are at different place, we can see the swapping. If they are at same place, no effect of swapping. Swapping will be definitely done. Then after that, call itself again by PERM, same string, then passing low plus 1 and high as it is. Call again for the next level. Then L is in, right? L was here, the next L is here, then L is here. So when it is coming back, it should swap alphabets at S of L and S of I. We are putting back the letters as it is, right? This was BA, then again it became AB for the next pass, right? Next pass. That's all we have to do in this for loop, and this all we have to do if low is not equal to high. If low is equal to high, print a string. So here, if low is equal to high, printf a string S, right? And all these things should be done, else all these things should be done. So here I write it as else. So this is inside else. And this is the end of the function. So that's it. This is a simple function. So you can trace this one and again generate a tree by yourself. And again, your work, paperwork is more important. And if you spend time on this one, then the problem is yours. Solution is yours. Right? Otherwise, just you have heard it once. That's it. And the coding is not much important here. Writing the program and looking at the result is not important. This contents you can find anywhere. Just you Google it, you can find the contents. But understanding it and tracing it and reframing it or making changes in this one by yourself, that is the more important, right? So if you work on this one, then you can find a solution for any other problem. So that's all.